Okay, good morning. I am from Malaysia. So I study different from the rest presenter. Actually, I am from the R&D agency, like under Ministry of Science, Technology, Malaysia. Okay, so I will share some experience on our R&D and certain our result have been used by the industry in Malaysia, and I will share some new research that have been implemented and then have been transferred to our technology discipline. In Malaysia company, they can use and market to local or international market. Okay, so thanks for PrimeKey invite me as a speaker to share the experience, and then one of our partner, Mr. Edward, Secure sent me here for the presentation. Okay, so I just give some brief introduction about our R&D Centre. So we are in the Malaysia, KL, and then we have another center in the northern Malaysia. So the KL center more focused on R&D. Oh, okay. Okay. Sorry for the interruption. Okay, so these are the way we're using the data in use or protection infra to form a lab in our research center. So I'm one of the lab under this info security. Okay, so there's some research and development experience that one already passed. We have done before. So that's a challenging for us. We built the CA engine by our own. Okay, when the researcher, average age around 5 of us, less than 30 years old. And then that time, we are young. And then we take a challenge from the management, say, we try to build. So we got a grant from Ministry of Science and Technology. And then 2 years, they give us 2-year grant. And then we built the engine for our Malaysian legislation department. Okay, so we went during this proposal. So there's 2 objectives only we set. So we totally forgot about throw away the technology. So we will try whatever we can. Okay, so we talked to the Ministry of Science and Technology and our the authority, the owner. Say we need to provide these 2 things only, called effective. The engine, they can issue the cert to MyKad. So these are the example live MyKad. This is the first generation of MyKad. I supposed to be changed, but I hold on first because I got some research still continue or still need support. And this card have been issued more than 10 years. Okay, I supposed to change the new one because the ISA key, the old one only 1024 bit. The new one should be 2048. Okay, and now I cannot get any certificate inside this card because the minimum key length is 2048. Okay, and the second is this: we have to try our best the cost effective issuance every cert. Okay, the mass insured to the every citizen in Malaysia. Okay, using MyKad. So these are our objective when we start the project. Okay. So after we think about it, then we do everything by our own. And all the module, all the system, we build our own, and then we are using C programming language, only one language to develop the entire engine. Okay? And then for security reason, so we try incorporate the HSM just for the key storage. And then CA engine to issue digital certificate on MyKad. And then our national legislation department have their own so-called personalized process. So we get them consultation from some of the officers. So we work together and then develop the entire issuance process based on our national legislation department requirement. Okay, all the process is based on them, we develop. Okay. And then after we develop the first version, it's a client server base. So some of them request, okay, they might have a web base for administrator. And then we restructure a bit the engine, and then we build the web interface for admin and also for issuance. And then challenging for us, not just build the engine. And the crypto token interface, cryptography token interface, we must build our own. Because why? Because the smart card is not from the manufacturer, not from the solution provider. So only we have to build it. Okay. The first, this called crypto key that we developed is using Microsoft CSP. Okay. And then we develop, we prove it working, and then some other requirement come back. How about other browser? Okay. So we do some research, and then we based on OpenSC, and then we build the other we so-called PKC11, support Mozilla and other web browser. They're using that PKC11. Okay, and then okay, that's finished already. But during the entire development, so we're facing another challenge. Okay, key basically for the key management or key protection, and our MyCard, they have a protection. We call it SAM. It call it Secure Accession Module Handshake. You want to write everything or issuance or anything that key generation to MyCard, you must go through this called Secure Access Module Handshake. And this is proprietary from our National Registration Department, and they built inside the card, MyCard. So we integrate that in order I can generate the key into the MyCard first. And the second, when you want to use, there's a pin protection for the private key, and then that we have implemented for the user side. Okay, and these are, we go through 2 years, and then we complete everything by 1.5 years, around that. And these are the sample page that showing to you that the engine managed to issue certificate. But in MyCard, I think they are some different from others. The standard are different from other smart card, which our MyCard have 2 types of certificate. Okay, so in every single card we got 2 types. One is certificate is called authentication certificate, and the second one is a non-deprivation certificate. So authentication, we use the cert, and both have the separate different key. Okay, so we not just generate the cert, we generate cert based on the requirement and the entity of the cert to meet the requirement of our National Registration Department. Okay, these 2 cert that we insert and we do. Okay, so after we complete that, then we demo, and then the entire system, or we so-called the copyright, everything, we transfer back to the government Malaysia. Okay, keep by them, and then they can free to use. And this system we cannot sell because it's very proprietary to the MyCard only. Okay, so after the research, and then we have some collaboration between Malaysia and the overseas European. So these are the example that research we cooperate with Hungary. It's a research center also, Institute Research Center. So they have this called pre-grade portal. It's for the grid computing. Okay, so they know we have MyCard, and then that time Malaysia actually got some ministry using that for doing the submission, the job. Okay, so they want MIMOS, or they want our lab to help is how to make MyCard that we can issue a cert to utilize the certificate inside the MyCard to this portal, make it more customized for localized in Malaysian market. So we work with this European Hungary Institute, and what we do is we are not going to do anything customized on the PG portal or submission. We only focus more on the security and the authentication. Okay, these are the job that we did for integrate or to work together cooperation with the PG portal. So what we do is we enhance the certificate mutual authentication using MyCard. But when transferred to them, they can use any other type token or any smart card for the authentication. So you see that this is how the page. You log they are even this login, they are using SSL or certificate, but login to portal still rely on the username password. So what we do is we remove that. Okay, we do some coding, and then we implement mutual authentication. Mean that login also using certificate, no more username password. Okay, and then we enable the HTTPS session using MyKad certificate or smart card based or any certificate based. And another problem we're solving actually is our so-called very good research output that we're solving the most problem happen for the basically to handle the grid, because the grid, when you want to do submission job certificate, right? How you keep the private key? So, for example, currently the PG portal, they all deposit the private key at the server. Okay. So what we do is we keep the private key at the client side, and then we will follow certain process and minimize minimize the process how the key being used by the grid computing and submission job. So I will show you this diagram. Basically, you see that if through the normal step of PG portal or any grid computing, so they're using my proxy as an agent for you to do submission job to create the proxy cert. So what we do is using the cert login from my proxy, then they generate the proxy cert 1, and then proxy cert 1 to generate another cert to submit the job. So what we do, we cut out one. So what we do is we not just using the cert to do the authentication. We can using that, okay, to generate the proxy cert only 1, and then using the cert, and then you can do the mutual authentication back to the grid computing, the grid GTK, and then you can do submission based on this proxy certificate. Okay, so the entire chain of this, we have published a few paper, and then work closely with the Hungary Institute of Research, and then I'm not sure whether they are keep it close or they open source. I'm not sure, but the PG portal is open source grid portal. Okay, so these are the continue after the MyKad. And recently, after that, so we focus because we learn from the key management. We know key is very important. Okay, success or fail or certain project, not because of the not strong encryption or not strong algorithm using. Basically, it's a key. We found it's a key. So I'm doing research, basically how to manage a key for past 1 or 2 years. So these are some results that we are doing. Okay, so why I involved within this research? Because of the certain, now everything in cloud. Authentication, then you will see the password get hacked, and then how damage the system. So from that, I try to study something, how to make it secure and simple to use and proper key management. Okay, so there's some problem statement that I found during my research initial state. So what we know that difficult in supporting different authentication requirements across the different application in the SSO. So I found that if this app, this application, this system, they have their own requirement, one requirement A, B got another requirement, C got another requirement. But when you want to do the single sign-on, so how you incorporate all these requirements into one? Okay, so these are my research. But basically, we solve it easily only, just based on the key management, how we handle the key. Okay, so another problem is a high cost of adding new authentication method to the existing app. So this happens when OTP token have some vulnerability, okay, and the private key can be hacked. So the solution provider take a long time, huge cost to migrate out. Okay, so the second, then difficult in integrate adaptive authentication, okay, in the mentioned environment. So these are another research area that I involved after I study on the key management. Okay, so from that, we have something called advanced authentication method. I think we have go through the previous presenter. They're using ECC. You can have an advanced authentication method. So we are certain security, we are depend on the ECC. Okay, so to achieve the first integrate all the app, so we have one single sign-on based on application trust specification, and we have adaptive to increase security. So you see that our research, one of the output that we have patented across international and local is secure barcode authentication. Okay, so what we do is, why we have this kind of idea? First is we compare to OTP and the SMS tag. Okay, OTP cost is what? The hardware distribution. Okay, and then for the OTP SMS, easy to distribute, but the cost per transaction, the SMS is a cost. So we take these two delimitation, or we so-called witnesses to develop our this so-called OBB virtual channel to the barcode authentication. Okay, so these are, I draw some diagram to illustrate how out of band can be achieved authentication. Okay, so actually you see this. These are the app that we developed in the, actually we support Android and iOS. Okay, so what we do is, you see that in plane mode, no any connection, no 3G, no Wi-Fi. Okay, so I will generate my credential. Okay, one click, this is a credential I use to log in. So we can't see any information, but the security to generate and to protect this piece of information, we are using ECC, elliptic curve cryptography, and using some elliptic curve mechanism. We generate the private key instantly when we generate. We don't store the private key. We generate on the fly. So based on, I think some of the presentation, so we go through that, but we have some modify on the certain flow to make suit our algorithm. Okay, so use that point and then you can log in to authenticate. Then we support multi-factor, mean that I not just support the username password. Okay, we support, we call it credential. We can have many type, or user can choose any type of authentication method you want to log in and to authenticate and log into the system. This is what we achieve. This method is one of the example. Okay, so to achieve, so you can see just simple, but we use 1.5 years to do research. But we take development, we take only 6 months to build the prototype or POC, because our team, not just research, we are all hardcore programmer. We are very strong in C programming. So even you see this, whatever we do, we are not using native language to build. We are using C in the library to protect our algorithm, to protect our flow or management. Okay, so with this, how am I going to send my credential to the server? So these are questions I'm asking myself. How? So I don't want connection. Because why I want to do something different to other. Out there market, everything push, right? Handphone send to the server, no unique. So I think about myself, how to make people think, wow, this is something that innovation from Malaysia. So I think about offline. Okay, so this has been achieved, but offline, how to send the credential to the server? So another challenge, we used a couple of months to study, and then we found out that actually thanks to Google, I went to Google some event, people talk about HTML5, and Google native support, all this. So start from that, I got idea. So maybe I can use HTML5 to transmit, that's why out of band, transmit my credential from my phone over the visual channel camera, and then send to the server, from the computer send to the server. So my device can be offline. So I can keep securely my credential to the trusted device, or just handphone like this. So these are the achievement we do. So we are using camera to transmit the credential, and then from the browser, send to the server. So the token or the device generation, the credential is offline. Okay. So for the advantage client mobile application highly secure because you own it and there have been no any connection and simple to use and administrative and admin cost effective solution for meet your strong authentication. So you see, we got objective, the solution meet that objective. So the first thing we need to cut down the cost, but we want to maximize the security protection. Okay, and these are some high-level architecture, how to achieve multi-modal or multi-factor authentication log into the system. So we have a trust level, low trust, high trust, the gateway that they can determine, okay, what kind of trust you want to authenticate user, okay. So the trust level based on we support this all our authentication method, certificate, 2D barcode, time constraint key basically is a soft token from the mobile, and then OTP SMS we support. So so how we evaluate whether the trust is enough, okay, to accessing the resources or application, the user authenticate, okay. So the application can set the level. That's why we let application set level. You set the level, and then user can choose any method they want. So when I log in using method A, so I have the value carry on this method, okay. Of course, username password is the lowest to carry in. So come to our engine, we evaluate, okay. So you see that, okay. Application trust specification and the input that you are required. So mean that trust required and trust you establish. So you see that the trust and the authentication input that you provided. So if you need more, you supply me less, sorry, I can't let you in. Even you can successfully authenticate. So what you need to do next, you maybe have another type, or you choose, the system will challenge you another type of method. You choose another type of method to log in to prove you are the person. Okay, now you see the trust established is slightly higher than the trust required by the application. And then after that, then I will successfully let you log in and recognize and continue that your work. So we focus more on this only, the authentication. So we can achieve that, okay, without like no like other product like this one is more on our research. We challenge you. We can let you multiple log in A, log in B, log in C, but we are not. I mean that until you certify the requirement, then we will let you in, okay. So in this kind of model, application can set the value you want, the trust, and the user also got choice what kind of method I want to use to log in, okay. So both user and the application have the choice, okay. So this function defined, this one I don't go too deep, and these are how we can do this. It's not I can do, it's my area I can do. So we help from few professor. Actually, it's a mathematics, they are more on mathematics. So we got a problem. They're using the mathematics or function way to solve it. So these are the diagram. They are simplified for me to do presentation. So you see the trust, low trust sufficient, meaning that if you want to have the trust level low, mean that no trust in, right? Mean that low trust means that for basic security requirement, just the basic, let's say username password enough, then they can log in. You can set even that, okay, to get the very minimum, okay. For certain application, okay, so you may set to high trust application for the authentication, and then this high trust means that you have to log in many times to log in. So maybe 2. So high trust means that you have to set some requirement, security requirement, and then if they say certificate is higher one, so if you log in as certificate, so it's a trust enough to establish for the application to accept to recognize and log into the system, okay, even with one authentication method or maybe 2 lah, okay. So these are the way we handling authentication. Okay, so the more complex is now the low trust, high trust is easier because it's static. The application say I want this, you must provide me this. Okay, user choose method. But what happens if you got another parameter? Okay, it's environment sensitive to determine. That means that they can deduce the user trust level. They say, for example, location, application, browser, or time of use. So I think this is very common, right? A lot of applications handle it. But what we handle it is how this environment will affect the trust value that actually normally they say, for example, low trust is normal practice day I do in office. All this meet the requirement meet on this. I can use username password to log in one. But let's say today I'm here, I accessing the same app. Okay, when I log in, username password, I'm supposed to be logged in, right? But because of the certain environment sensitive change, for example, location change, so I may or maybe get challenged. Okay, because of the environment change, my trust value, the level will drop. Okay, and then because of location change, so I need to provide additional input to the system, say, yeah, this is me, and to increase my trust value. And then the app will be accepted me, and then log in. Okay, so you see, from though this adaptive authentication and the trust value, the trust engine, okay, combine all these, at the end we found out something interesting. Okay, there is a trust of, is a key that today title. So this is not like we come on initial research. At the end of research, other that we achieve our objective, and we found after we implement this, the trust actually is a key. You can, so today, before that, I think my key is all my, when you're talking about key, either private key or secret key, right? But after our research, we found that the trust value, the trust can be a key, okay, for the person or for the system to work together to maintain the security level and the trust value, the trust for authenticate the user. Okay, these are the last that we found, the output of our research. Okay, so that's why I bring my title, change a bit to trust is a key, or because of this, the research output that we generate after we complete our research, and then we found this trust is a key. The trust value can be a key for the application to recognize the user. Okay, so my last slide conclusion is enable public key application incorporate research and the personal key inside the MyKad. This only we can do it in Malaysia. Okay, so far I think in MIMOS, in our organization, for programmer for handling the MyKad, I think left 2% only. Few person, we got few, last time we got 2 or 3, but they already left. So far, myself and the other engineer, I trained a new engineer handling how working with MyKad. Okay, so the trust is a key for secure, trusted authentication. And I will share something with you, okay, before I end my presentation. So after that, we found offline is a trend or is a future may interest by a lot of researchers. So my initial research, actually we asking for funding. We may get funding from our government. And potential the work, okay, we are using some called certificate-based PKI concept, okay. But we define, because we learned from previous key management, the trust, and we will define some key secure key management protocol to enable local offline user authentication. Okay, but this one we are still on our research, and we have a target. Actually, we have a target ministry agency where they interest to use this, which is our Ministry of Health. Because the problem today, Ministry of Health is when offline, they cannot do anything. The counter closed. So this may be solving this problem. So while the network off, but the counter still can operation as normal. So when the network up back to in operation, so they can sync back the data to the cloud or to the data center. These are few challenging components that we are focusing right now, okay, for offline user authentication. So hopefully I can use your EGP ACA as a start. Maybe you are using the community version to try out, see how this can work together with our solution. Okay, so thanks. Thank you so much.
I'm sorry for being the annoying kid in class, always with the questions. I got a question to the barcode scanner. Are you relying on the user to put the phone into the airplane mode, or do you, because you mentioned you're using native C to actually implement the functionality on the device, or are you able to switch the phone into airplane mode yourself before any of these steps happen, or how does it work under the hood?
So actually, the application here in our phone here is, whatever you're in airplane mode or in any mode or 3G, we are not using any internet, because you know that we want to you build your security, you have to add in all the function, right? We are never add in the network. So you are in a 3G mode, any internet, Wi-Fi, fine. It can work with the barcode can be generated. So we are not dependent on that.